All right, we are back to look at another example about molarity and another instance in which we are going to have to use multiple formulas in one problem. So in this question, we are asked, what is the mass of barium fluoride in 1 liter of a 1.4 molar solution? So just to recap for us, molarity equals moles per liter. So first, let's just go through the data, think about what we have, what we're asked for. So we know that C is 1.4 molar, or moles per liter. We know that V is 1 liter, and we're being asked for the mass. To be able to get mass, some other things we're going to need to figure out. We'll need to figure out the molar mass of barium fluoride, and we also will need to determine moles. So the equations we're going to need are C equals N over V and N equals M over MM. All right, so looking at the pieces of information that we have, the first thing that we'll probably need to solve for is the number of moles of barium fluoride, which means we're going to be looking at this equation here. So our first step will just be to make sure we properly rearrange the equation to isolate N. And the way I'm going to do that is by multiplying both sides by V. That allows us to cancel out the V on the right side of the equation because anything divided by itself is 1. And then we're left with the equation N equals C times V. And then we are just plugging in the data from our data list off to the left. If the concentration or the molarity is 1.4 moles per liter and we have 1 liter of the solution, then that makes the math nice and simple for us. We are just going to have 1.4 moles. So now that we have moles, we're going to be able to take that into our other equation to be able to solve for the mass that has been asked for. Now what we're also going to need to remember is that we need to find the molar mass. So this is where our naming and all the IUPAC rules come up again, because we know that barium fluoride, we should know that that's BaF2. And then we've practiced how to calculate the molar mass of something quite a bit. So you will be able to determine, once you look into your periodic table, you would know that the molar mass of barium fluoride is 175.324 grams per mole. So now we have molar mass and we have moles, and we can sub both of those in to our other equation. So N equals M over MM. And again, we want to isolate mass on one side, so I'm going to multiply both sides of the equation by the molar mass, which gives you mass equals moles times molar mass, or 1.4 moles times 175.324 grams per mole. Notice how I didn't round too much there. I want to carry more data towards the very end. When we type that into our calculators, what we are going to get will be around 245.4533 grams of barium fluoride, or if we round that off to 2 decimal places, 245.45 grams. And that would be our final answer for our therefore statement. Therefore, the mass of barium fluoride is 245.45 grams. And then just to recap there, you'll notice how we needed to use the C equals N over V formula, and we also needed to use N equals M over MM. So that's why writing a data list will be super, super helpful for you when solving problems, because if you can quickly identify what do I have and what do I need, it makes it a lot easier to identify the relevant formulas. So we just plugged in all of that data into our formulas, we arrived at the final answer, and that's the mass of barium fluoride in the solution.